Hello students. In today's class, we are going to learn about units and measurement, some rules of significant figures, and finally we will learn how to apply them in solving a math problem. So let us start. Anytime you check the weight on a scale, you look for the ingredients of a recipe, or you look for GPS, how far is your college from home, you are always measuring some kind of quantity, right? When we work in a healthcare professional, we take weight, we take blood pressure, and we take vital signs like temperature of the patient to chart their progress. So measurement of the units are important in our daily life. The number without the unit is meaningless. Okay, so always we have to place or write down what is the unit we take while measuring certain signs or doing the measurement. There are different types of system to measure things like length, volume, or mass. We can do the measurement in metric system. We can do it in SI system, which is actually international system of units. Okay, or we can measure them in English units. And here in US, we generally follow the English unit. So let's see how these measurements are related with the units. If you are measuring a length of a ribbon, in metric system, and SI system, we measure in meter. Okay. In English system, we might measure in miles or yard. Volume, we measure in liter, in SI in cubic meter. Mass, we can measure in gram, and SI unit is kilogram. In US, we measure the mass in pounds and like that. Temperature can be measured in degrees C and Kelvin in SI system. We measure time in seconds. So seconds are the units of metric system. We can measure time in hours, days, and seconds. Okay. So, and as I mentioned you that we can use several different systems. Let us first look on the metric system. In metric system, and you might have seen these metric system before in your high school, so we are refreshing some of the things you learned there. And in metric system, all the units are related to the base unit by a power of 10. Let's say if I'm measuring the length, I'm talking about meters, right? So I have few prefixes of the units that indicate whether those measurements are larger or smaller than the base unit. Okay, generally we use uppercase symbol for the larger ones. For kilo, we simply go for lowercase k, and we use the smaller lowercase letters for the smaller prefixes. Okay, so and how they are related, let me talk about that here. Let's say I'm talking about meter, then your centimeter, 1 meter will be equal to 100 centimeter. Okay, or 1 kilogram will be equal to 1000 grams. So when I say kilo, I'm talking about 1000, 10 to the power 3 from our base unit. When I say mega, then it is 10 to the power 6 or million times larger than our base unit. Okay, gigameter, it means it is 10 to the power 9 meter. Okay, similarly on the smaller units, deci, centi, milli, micro, and nano are generally used. As the prefix sounds, centi means it is 100 times smaller than the base unit. Milli is 1000 times smaller, so it is 10 to the power minus 3 we write, and micro is 10 to the power minus 6. and nano is 10 to the power minus 9. You can learn all these metric units and you can convert from one unit to another if we know this mnemonics, where the first letter of these mnemonics are staying for the prefixes here, okay, the symbols. So great mighty King Henry died by drinking chocolate milk, maybe not, will be like giga, mega, kilo, hecta, deca. By is the base unit, lowercase d is the deci, c for centi, m for milli, and maybe not this m for microsign, and n is for nano. Okay, how do we remember this? Is from, well, going from base to each larger prefix, we multiply by 10. Okay, and from kg to mighty, we multiply by 1000, and some from mega to giga, we multiply by 1000. Okay, so let me show you this in a board over here. Maybe that will be more clear that way. Okay, so let me choose the pen over here. Okay, let me write great mighty King Henry died by, okay, it will take a while to understand it, but once you learn it, it will be very easy to convert one unit from another. Drinking by, died by drinking chocolate milk. Okay, maybe not. Okay, the reason that I'm putting the giga, mega and kilo in a stairs and all of these units on a same line, on the same step, and from milli to micro I am dropping the steps, because while going from kilo to mighty, you have to multiply by 1000, or there is a 10 to the power 3. They are different by 10 to the power 3 powers. Okay, it means the mega is larger than kilo by 1000 times. So when you go from giga to mighty, it's again 10 to the power 3. And I will show you how to remember all this in a while. And now between them, it's the difference of 10 times. Okay, so all these is the power of 10 to the power 1. From centi to milli is 10 to the power 1. And now from milli to micro, okay, so 1 milligram is 10 to the power 3 microgram. Okay, so our 1 microgram is 10 to the power 3 nanogram. Okay, it means nano is the smallest over here, and the giga is the largest among these units. Okay, so now let's say the question is convert 5 kilogram, okay, convert the 5 kilogram, 5 kg into microgram. Let's say question is something like that. Okay, then we can write here 1 kilogram is 10, right? Another 10, another 10, another 10, another 10, another 10, and times 10 to the power 3. So 1, here is 1 0, 100, 1000, right? 10,000. Similarly, so behind 1, I have 1, 2, 3, 4, 5, 6 zeros. Okay, when I have 6 zeros, 2, 3, 4, 5, 6. I have reached here. So 1 kg is 10 to the power 6 milligram. And then I have now 3 zeros here, right? 10 to the power 3. Multiply by those. That will give you 3 more zeros. That many milligram are there in 1 kilogram. Okay, that is how we convert the kilogram into microgram. So now we will cancel the kilograms here. So 5 kilogram is equal to 5. Behind 5 we will have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So 5, we can write this as 5, 9 zeros. After it, microgram. We are here on the microgram. So you can always start from the larger prefix and then find the relation with that, how much is the smaller prefix, and then we can convert from one to another. Okay, and we are going to use the conversion factor. So what I am doing here is using the conversion factor. I'm converting the kilogram into microgram here. I'm writing that relationship so that I can use that relation to find how much is 5 kilogram in terms of microgram. Okay, so I am all explaining this so that you know. Okay, you know this relationship. Now, there is some metric equivalence as well as the English unit with the metric units. Okay, for example, how 1 pound is related with the grams. 1 pound is equal to 454 gram. Here is not written. 1 gallon, right? 1 gallon is 4 quart. 1 gallon is 3.78 liters. So we have some standard relationship that shows the relation between metric and English unit. Okay, so this is also something that you can look up in. Now since we are going to talk about the measurement, everything has a number and a unit, right? Now let's talk about the number in them. Those numbers could be either exact or could be measured numbers. Okay, generally, whenever the number are result just by counting the objects or it came from the definition, then we call it exact number. For example, I count my 10 fingers, right? 1 meter is always equal to 100 centimeter. It is a defined relationship. So these numbers here are called exact number. Okay, and whenever we obtain the number by doing some kind of measurement, by using the devices or some kind of tools, by doing some observation, then we call those number measured number. And measured number always comes with some uncertainty. That uncertainty is because of the instrument, the tools that we are using. Okay, so here the measure number, we have to think about how many significant figures can we write for that measured number. That's why we need to learn about how to determine the significant figures. Okay, and how many significant figures can we write depends on which kind of apparatus, what kind of tools and devices, what is the sensitivity, the uncertainty of that device is that it depends on it. When I say significant figures for the number, I'm talking about all the digits that are in the measuring number. It also includes one estimated digit. Always the digit that comes on the very last is the estimated digit. Okay, let's understand this by looking at one example. It will be much clearer. Okay, Let's say you need to know the length of this stick. Okay, so you have a tool, a measuring tool to measure the length. You put your ruler against that stick and now you look upon how much it is, right? In case A, you do have the graduation, right? In the ruler, it shows like these lines show you that you have certain about 4, and then after that you have to do the guess because there is no number in between 4 and 5 here. There is no division, right? There is no gratings between 4 and 5. So 4 you are sure, after the decimal it is what number you can place, that is your estimated guess. So that is your educated guess, right? Some of you might say, oh, the ruler looks like the stick is right in the center of 4 and 5, so I will go for 4.5. Other might say, oh, it looks more like 4.6 to me, and that could be also correct. But you cannot say the digits more than 4 point something. Okay, 4.5 or 4.6. You cannot say 4.666 here or 4.555 here. You are limited by one estimated digit after your certain digit. So here 4 is your exact, right? The 4 is your certain number, and then after that 4, the number that comes is your estimated digit. Let's say in the case of B, now you are using another ruler that has the divisions, graduation between 4 and 5. So now you see here your stick is 4.5. Those are the certain numbers, and now you can add one more estimated one, the guess number, and it looks more like in between these two lines, so you can go for 4.55 centimeter. And you have to stop there. Okay, so now it has 3 significant figures in this reading. In C, again, we do have just 3. You are certain about 3. After 3, you are not certain. So after 3, you can estimate only one more digit. It looks more like 3.0. So you can write 3.0 centimeter. Here we have just 2 significant figures in this reading. Okay, so that is how many significant figures can we write for particular measurement depends on the tools, depends on that uncertainty, how many we can write it. Right, so where we can stop. So how do we determine sig fig? You might have heard me, I was telling I have 3.0 means 2 sig fig. I have 4.55 means 3 sig fig. How did I say? How did I count that sig fig? There is a rule. How can we determine the significant figures? So let me talk about it now. Okay, so if you have in the number, all of the number are non-zero digit, then you count all of them. Okay, so you have here 4.5 is 4 and 5 both are non-zero, so 2 sig fig. If we have 0 in the number, now we have a confusion whether to count it or not count it. So we have to follow the rule to see it. Okay, it depends on where the 0 is. Such as here, if the 0 is between the non-zero digit, we have to count that 0 as a significant. So now we have 3 sig fig here in 205. If the 0 comes at the end of a decimal number, such as 25.0, again we have to count that number. So total 3 digits there, 3 sig fig. Okay. Any digit in the scientific notation in the integer part has to be counted. The 0 in the base 10, you cannot count it. You should not count it. So here in this example, 4.0 times 10 to the power minus 3 means we have 1 0 here, right? That 0 is significant, and now we have here two digits, so we have 2 sig fig. Then you might say, when do we not count 0 as a significant figures? Here are two examples. If the zeros are at the beginning of the decimal number, right? If the zeros are there used as a placeholder, like cosmetic size, right? Just to show that this is not 4, it is way smaller than 4 by 10,000 times, then we write here 0.000. All these numbers are insignificant. Okay, that's why only 4 is the significant figure here. So sig fig is 1 for this number. We'll do exercise, don't worry. Similarly, if you have a large number with no decimal, then all these zeros after the number that are used as a placeholder, these zeros are not counted as a sig fig. So now we have, for this number, 2 is the significant figure. 8 and 5 is counted, 2 sig fig. Okay, so this is just the rule to count the significant figures. Okay, it does not mean that 85,000 is equal to 85. It does not mean that. Okay, sometimes students feel confused, like when I say 0 is not significant, does not mean that you do not value it. It's just like when counting as a significant figure, we do not count that 0. Okay, it feels like a little bit overwhelmed with all these rules over here. I would like to give you a tip, okay, a hack, how to remember all these rules without memorizing that rule. Okay, so let me allow here to draw a rough diagram. Okay, a rough diagram about USA. Okay, a map of our US. And all of us remember that we have Atlanta on our east side. So we have Atlantic Ocean, right, on the east. And then we have Pacific Ocean on the west side, right? For this hack, you just need to remember A and P. Okay, you do not need to remember all this. I just need A and P. So P is for present. So I'm going to write here present. And A is for Atlantic, not Atlantic. A is for absent. Okay, let me see if I can choose that box. Okay, it does not allow me. So A is for absent of something. So what am I looking for in a number? I have to look for decimal in a number, okay, to find out whether the 0 is significant or not. And then what to do after figuring out the decimal is present or not? If the decimal is present, then I have to start counting from the left-hand side. Okay, if decimal is absent, I have to start count from the Atlantic side. Okay, and now we have a little bit to remember. How do we count? There is a method. A correct method to count is we will not count any non-zero. We will not count we have to start counting from the first non-zero number and keep on counting from there. Okay, what do I mean? Let's check here with our first number. Okay, our first question is, how many significant figures do the following measurement 2730.78 has? Okay, right away, when you see this question, you look for decimal. Oh, this system has a decimal here, right? So if I have a decimal, it means I have to start counting from the left-hand side. And the method to count is I have to start counting from the first non-zero number. First non-zero number is 2, and all those numbers behind it, I have to keep on counting. Okay, I cannot stop. So it means 1, 2, 3, 4, 5, 6. This first number has 6 significant figures. Okay, so let's work on the second one, 0.0076. Again, this number also has a decimal. So I have to start from the Pacific side, from the left-hand side to count. But when I start counting, I encounter these 000, which are zeros. So I don't count them. We have to start from the first non-zero number, which is 7, and then keep on counting all the numbers who are behind it. So 7 and 6, I have two numbers. So significant figures of this number is 2. Okay, so I think now you feel a little bit, fun to try this. Let's try the third one. 3400 kg. How many sig fig? Is there a decimal? No. Then it means I have to start count from the right hand side. I have to start count from the right hand side and start counting from the first non-zero number. 4 is my first non-zero number, and after that I have 3. So I have 1 and 2. So just 2 significant figures in this case. I think now without thinking a lot, you can try on these questions. Like decimal means I have to go from this. So 1, 2, 3, 4, 5. All of them are sig fig. Right? This is all non-zero number. So 3 over here. Right? And now I have here 10.003. This guy has a decimal. So I have to start from left hand side. So 1 is the first non-zero, and now keep on counting all of them. Okay, so 1, 2, 3, 4, 5. I have 5 significant figure on this number. Please try the following ones. 0.1400. How many are there? 35 cents. This is just 2 sig fig. You just learned it. Okay, so please understand and practice this hack. Okay, this hack will cover up all the rules that we just saw for the significant figures. Okay, so only thing that I did not mention is the numbers on the integer of the scientific notation. Those give you the significant figures. Okay, not the base 10. And I think we will talk about it just in a while. Okay. So how do we apply that significant figures counting in our regular math? Okay, so we have 2 more rules. One rule is for multiplication and division. The other rule is for addition and subtraction. Let's look on this. Okay, the rule says whenever we are doing multiplication or division, in that case, the answer has or should have just the same number of significant figures as the original number with the fewest significant figures. Follow the few. Okay, so let's do this with an example. Let's say you have to do the math. You have to divide 351.2 by 5.5. If you do this division, the calculator will give you all these number on the calculator, but you have to report the final result number in correct significant figures. So we have to follow this rule. The rule says we have to have fewest significant figures, right? The answer should have the same number of sig fig as the original number with the fewest sig fig. So let's count. The original number on numerator has 1, 2, 3, 4 sig fig. The denominator has just 2 sig fig, right? So this one has a 4 sig fig and this one has a 2 sig fig. So it means I have to write the answer in 2 sig fig. And well, in order to write the 2 significant figures for all these numbers, I have to do round off. Okay, so in round off, if I have to drop the number behind the decimal is larger than 5, then I have to add 1 to the preceding number, right? If the number behind the decimal is smaller than 5, then I have to drop that number simply. Right? So I can write 63.854545 as 64 miles, and now I have 2 significant figures in this number. That is a correct sig fig. Okay, so we always have to count the fewer sig fig, which one is the fewer, and stay with that. In the case of addition and subtraction, when we are doing that math, okay, now this time we have to count the decimal place. Okay, so decimal place is like how many digits are there after the decimal. So 3.18 means I have 2 decimal place here. 0.01315 means I have 1, 2, 3, 4, 5 decimal place, right? All these numbers are behind the decimal, so I have 5 decimal place. So when I add these numbers, the answer should have the same number of decimal place as the original number with fewest decimal place. Okay, so fewest decimal place is 2. It means I have to have just 2 digits after the decimal. Okay, so when you add this number and that number in the calculator, you might get many numbers, but you have to write in such a way, report your answer in such a way that it will have just 2 decimal places, just 2 digits after the decimal for this case. Okay, so that is the rule about addition and subtraction. If we come up with a math calculation where all the multiplication, division, addition, subtraction, every operation is there, then just like regular math, we follow PEMDAS rule. We have to keep the track of the sig fig using the PEMDAS rule. And finally, at the very last step, we write with the correct sig fig. Okay, so rounding off we always do at the end of the problem. We do not do rounding off in every intersection, okay, intermediates step. So with that, let's look on what do we have. Okay, scientific notation, right? You had seen a number earlier. I told it was written in a scientific notation. So let's see what are the parts and how do we convert certain number into scientific notation and vice versa. You will see whenever we have a very large number or very small number, it is a lot convenient if we write that number in a scientific notation. The scientific notation has 2 parts. We have some coefficient, okay, and then times 10 to the power, some 10 to the power, and that is power is x. X could be any positive or negative number. Okay, 10 to the power. X has to be a whole number. And the coefficient should always be a number between 1 and 10. It cannot be larger than 10. It cannot be smaller than 1. Okay, so with that rule, let's see how to convert that. Here is an example. Convert these numbers to scientific notation. I have 2500. I have to write, this is the expanded form, standard form. And the question tells me convert this into scientific notation. So I have to write this in 2 parts. The first part should have the integer, right? And the second part should have the base 10. So how do I do it? Let me suppose that there is a decimal on the end of this number. Okay, now you imagine moving that decimal to the left 1, 2, 3 places, so that now you have 2.5, and 2.5 is the number between 1 and 10, right? And times 10 to the power, how many move that decimal you had to do? So you had to move the decimal 3 times, right? So it is 10 to the power 3. Another way of looking at it is a power will be positive if your number, the standard number, is greater than 1. The power will be negative if your given number is smaller than 1. Let's check this example. 0.036, you have to write in scientific notation. How to do it? On this case, you already have a decimal. You just have to move that decimal to the 2 places, right? So that now your integer is 3.6. You cannot write 36 because 36 is larger than 10, right? You cannot write 0.36 because 0.36 is smaller than 1, right? The number has to be greater than 1. So we have to think about this window, right? Those integers should be in between them. And then rest is looking on the power, whether it will be positive or negative. If you move the decimal to the right, the power will be negative. If you move the decimal to the left, the power will be positive. If that thing is confusing, then let yourself tell that if a number is smaller than 1, you will have a negative exponent. If the number is greater than 1, means very large number, then it has to be a positive power there. Okay, I hope that explanation helps you to remember this. And now let's dive into utilizing the significant figure rule now in the problem given. Okay, so we just learned about the different units today, right? And I mentioned that we can convert from one unit into another. We can use the conversion factor to do that. Okay, so let me explain what does the conversion factor mean. It is a term that converts a quantity in one unit into another. So whenever we have to solve a problem converting from one unit to another, we have to use the conversion factor. So what is a method? The scheme is you have to start with the original quantity, multiply the original quantity with the conversion factor, and you will get the desired quantity. When we write two units in different units and we write the defined relationship between them, we are talking about equality. Okay. 1 kilogram is equal to 2.2 pounds. This is a defined relationship. Okay, so it is something like A is equal to B. When A is equal to B, then in math, we can write A divided by B is equal to 1, as well as B divided by A is equal to 1. Okay, so it means that from equality, we can always write those as a fraction. So from this equality, either you can write 2.20 pound by 1 kg or 1 kg divided by 2.20 pound. Okay, so now depending on what we need, we will pick a correct conversion factor and use it in a problem. Okay, so let's try that. We have here, I wanted to get rid of that box. Okay, now we have here a problem. If you know there are 26.22 miles in a marathon, how many kilometers are there in that marathon? Okay, so here just looking on the question, we can understand that we have miles that is given. We have to convert the miles into kilometer. In order to do that, we have to use the equality or the conversion factor, right? Equality is the defined relationship 1 kilometer is equal to 0.6214 miles. This is the SI unit and the English unit equivalent, okay, when they are equal. So let me start with the question. The given quantity is 26.22. I place that here, miles. Now the starting quantity I have to multiply by the conversion factor. I could have conversion factor like 1 kilogram divided by 0.6214 mile, or I could write 0.6214 mile divided by 1 kilometer. So I will have two conversion factors here. Okay, so now which one to choose? I have to always see or set up the problem such a way that the unit in my starting material has to be cancelled, and I have to retain the unit that I need in my question. okay, in my target, in my destination. So if I start with miles, then I have to have the miles on the bottom and kilometer on the top. So I write the conversion factor 1 km by 0.6214 miles. And now my miles and miles cancel out because it is miles multiply 1 by miles, right? So miles divided by miles is 1. And 26.22 divided by 0.6214 will give you the answer in the calculator 42.2. Okay. And then if you look back, we have 4 significant figures, right? Start from the Pacific side to count it because we have a decimal. So 1, 2, 3, 4. We have 4 sig fig in the starting number. So we have to report the answer in the 4 sig fig. Okay, and here the hint is the numbers provided in the problem should determine the significant figures, not the conversion you look for. Okay, so don't worry about the conversion number. These numbers are the exact numbers because they came from a defined relationship. The 26.22 miles is the measured number. It has the uncertainty. We have to talk about significant figures for them. Here we have 4. So if your calculator just shows 42.2, then you can add 0. So now we have 4 sig fig here, right? 42.20, which is the equivalent quantity. So that is how we work on that math over here. Now let's try few questions. Okay, in order to work on this, there are certain steps that we took in. So let's review that. Whenever we have to work with problem solving using the conversion factor, very first thing is you have to analyze what is given. You have to find out what is needed or what we have to find out. Then make a plan, right? A mental plan, how to convert from one unit to another. You have to write the equalities. When you write the equalities, you can come up with the 2 conversion factors. Then you set up the problem such a way that you cancel out the units in the starting number, and then you come up with the calculated answer, and then with the unit that you want, and then you can always finally look for the correct significant figures. How many can you report? Okay, so those rules of sig fig we learned, that has to be applied here. So let's see one example. If a person weighs 164 pounds, what is the body mass in kilogram? If you analyze the problem, 164, the pounds is given, kilograms is what you have to come up with. So you have to convert the pounds into kilogram, right? How to convert that? You have to bring a equality. 1 kilogram is equal to 2.20 pound. Now you can write that equality in these conversion factors. You start with your given quantity, 164 pound. Since you have a pound here, you want to choose the conversion factor that has a pound on the bottom. So you bring that over here. You multiply your conversion factor, the correct one. Then pounds will cancel. You will have kilogram as a unit. And then you multiply 164 by 1 and divide by 2.20. You will get answer. You go back and see how many sig fig are there in your starting number. There are 3 significant figures, so you report your answer in 3 significant figures. Okay, so let me work with calculator. What is the number we get? If I divide 164 by 2.20, I actually get 74.54545455 in my calculator. I cannot write all those numbers here, right? To report that number with the correct sig fig, I have to follow the few. And here I have just 3 that I have to follow. So I just write it in with the 3 sig fig. And if you remember the rule, I have here to count from the Pacific side. 1, 2, 3. So it is 3 sig fig number. Okay. So there are a few more questions here, and this video is going to be a little lengthy. If you are tired or something, if you want to go for a drink or something, you can pause here. Okay, go get a drink and then come back, and then you can continue on the video. Okay, this is about the all working with the problems, and in your lab also you will have a lot of exercise to do, like introduction to math worksheet. So yeah, let's look on this question. I encourage you to practice more and more questions like this. Okay, once you have a hang of it, it will be so much fun to set up the problem, get the answer. It's a lot of fun. Okay, so let's see this question. A doctor's order prescribed a dosage of 0.150 milligram of synthroid, some kind of medicine, if tablets contain 75 mcg. Mcg means microgram. Okay, so in healthcare profession, what they use is when they write micro sign, that might be very confusing, that might be ambiguous with the letter M, lowercase m. That's why they started to write mcg, so that there will be no confusion. Okay, so this is a microgram. So microgram of synthroid. How many tablets are required to provide the prescribed medication? Do not worry if the question looks lengthier. Okay, because sometimes we may need to use more than one conversion factor to reach the correct unit. Okay, so that's why, but don't worry, I'll teach you how to do that. We have a given number 0.150 milligram, and then it says if tablet contains 75 microgram, it means one tablet is equal to 75 microgram. That is the conversion, that is the equality given there. We can use that equality as a conversion factor. Okay, so given is milligram, we have to go from milligram to microgram, and then we have to relate the microgram with the how many tablets we can make it. Okay, how many tablets do we need it? So that is the plan, how to reach to the number of tablets. So let's set up what we need. So we had microgram to start with, right? 0.150 microgram, sorry, milligram, my bad. Milligram, I have to convert the milligram into microgram. So what is the relation that connects these two units? It is 1 milligram is equal to 1000 microgram. Okay. If you remember that great King Henry died by drinking chocolate milk, maybe not, right? Milk is milligram, maybe not. That M, maybe, is the micro. So we have 1000, it is 10 to the power 3 microgram is equal to milligram. So I can write this equality in two conversion factors like these. Similarly, we are given the equality in this question right here. 75 mcg is there in one tablet. So one tablet is equal to 75 mcg. I can write in these two conversion factors. Now let's move on. We have here starting quantity. I write the starting quantity. I have a milligram here. So I need to write the milligram on the bottom. So out of these two conversion factor, I pick the first one. Okay, I pick the first one because this guy has the milligram on the bottom. So I place that. And then it will have a microgram mcg on the top. This is something that I do not need. I need the number of tablets. So I have to place now this conversion factor because I need to cancel that mcg, right? And then I have to retain the tablet. So I have to set up such a way. Okay. So now if I use these two conversion factor with the starting quantity, if I multiply them, then milligram cancel out, microgram cancel out, and the tablet is the one that remains. And let me do this in calculator. 0.150 times 1000, okay, times 1. That is 150. Now divide that 150 by 75, which is on the denominator. It gives me the number 2 tablets. Okay, so I get here the answer 2 tablets. Okay, so that was it. Okay, we did that question. Now let's see we have any more to do. Okay, more to practice yourself. Okay, please go ahead and work on these problems. I will also have the introduction to math video to help you on your lab side, and that will give you a good exercise. With these exercises we just did, you can also work on these problems. If you have any question on these, please write to me, reach out to me, and I will be there to help you. Okay, so, and don't forget to always report your final answer with the correct number of significant figures. Okay, do not write all the numbers that you get in the calculator. You have to round off to the correct sig fig after you are done. So, the other small topics that we will be looking at in this chapter is about the temperature. We can measure the temperature in degree C or degree Fahrenheit or Kelvin. And here are some relationship if you need to convert from one to another. Okay. And density is something that we talk about here in the measuring. Density is actually a physical property that relates the mass of a substance to its volume. So the density is defined as mass per volume. Okay, so we can use the dimension analysis or unit conversion method to find out when 2 of these variables are given and the third is unknown. Let's try this question. If the density of acetic acid is this much, 1.05 gram per ml, what is the volume of 5 grams of acetic acid? Here the density is given, the mass is given, and volume is asked. You can either do volume will be like you can cross multiply here. Do volume is equal to mass divided by density, or you can just work through how we just learned. Excuse me. Okay, so you have to have here, start with the 5 grams, and you do have here 1.05 gram per ml. It means every 1 ml is equivalent to 1.05 gram. So you have an equality there, right? Make the correct conversion factor and then multiply that correct conversion factor with your grams. The grams will cancel out and then you will have ml left. Okay, so when you do that, 5.0 gram times 1 ml divided by 1.05 gram, the grams will cancel out. And your calculator will give you 4.76 as your answer. You have 2 significant figures over here. So you need to report your answer in 2 sig fig. So you will write your answer as 4.8 because the 7 is greater than 5. So if you need to drop the the 6 is greater than 5. If you need to drop the 6, then you have to add 1 to the 7. So you have here 4.8 ml. That is the volume you are looking for. Okay. Okay, please cross-check your answer with my answer here. And now, the very last one, I think you will be able to work on this problem by yourself. A glass stopper has a mass of this number. The volume of that, what is the density? Oh, it's simple. Mass divided by volume will give you the density, right? So centimeter cube, do not get afraid. Centimeter cube is equal to 1 ml. Okay, so you can have here gram per centimeter cube as a unit, or you can write gram per ml. So that's all in our chapter number 1. Please practice, review these questions we did today, and practice more of the conversion factor related question. Okay, practice working with significant figures, counting, and how do we round off, all that. Okay, see you in next chapter. Thank you.